In this video, we're going to talk about the different types of audio cables and connectors and why we use them, why we use the different formats. I'm going to make up a couple of adapter cables to go from XLR to unbalanced. And we got a bonus coming up at the end. We're going to do an experiment with some tape-based equipment at the end. Today, in this quick video, we're going to go over audio connectors, different types of audio connectors. So, most people are familiar with your standard, what's called an unbalanced audio cable. Something like this, right? You've got an RCA plug in the end, or it could be a phone plug, right? Like your headphone plugs. It could be a phone plug, or it could be just a regular RCA plug. Now, the interesting thing about phone plugs is that they can be used for balanced audio if you're using a stereo plug, and a lot of professional amplifiers will actually use a stereo audio or stereo balance connector, stereo headphone type plug for balanced audio, but we're not going to deal with that in this one. But it works exactly the same as if you were dealing with this. So you can think of this as the same. In the case of dealing with a 1/4 inch phone plug with a balanced audio, you got your ground, you've got your positive audio, you've got your negative audio, which is exactly what the XLR connectors do. And that's what we're going to be making up in this particular video. We're going to be making up a couple of patch cords, but we're going to be making up patch cords that transform a balanced audio into an unbalanced for line level operation, because that VTR that I picked up, well, it uses balanced and unbalanced connections. It uses XLR, which can be wired either way for either balanced or unbalanced operation. So I've got 2 male and 2 female so that I can have both inputs and outputs ready to go. So we're going to make these cables up here. I'm just going to use a sacrificial cable that I'm going to use. And we're going to wire these up. But before I wire them up, I'm going to show you how to wire them, because there's a right and a wrong way, and if you get it wrong, well, things probably aren't going to work properly. And in some cases, you could cause damage to your equipment, so pay attention. Now, the first question that everyone asks is, why do we use balanced audio? What exactly is the purpose of it? Anybody know? Bueller, you know? The reason is, and it makes no difference when you're dealing with short runs, and that's why most consumer audio equipment will not use balanced audio. It's usually used on pro equipment, commercial equipment, because the length of cables is longer. Typically in microphones, if you're doing sound reinforcement like at a performance, a live performance, for example, and you've got long microphone cables that are going from your performers over to the stage, or the edge of the stage where you're plugged in, or all the way back to the soundboard, you're typically running longer runs of cable, and this is where it becomes a problem. In the shorter runs like this, a little 6 or 10 foot cable, this is rarely going to be a problem. But in longer runs, it becomes a real problem. And what happens, and I've kind of drawn a little diagram here to kind of illustrate what happens. So here's your cable. This is to represent the coaxial cable that's inside this regular RCA type connector. This is the braid. I haven't drawn the braid in here, but this is the braid that surrounds the center conductor. Okay, there's your braid. You get your braided shield that surrounds the audio connector. That's a coaxial cable. All coaxial cables are exactly the same. It doesn't matter whether it's your cable TV plug, or if you're using Ethernet over coax, MoCA, same thing. Satellite cable, antenna cable for your TV antenna, unless you're using the old twin lead. Antenna cables for two-way radios, etc., or to a satellite dish. Coaxial cable is all the same. It's got a braid that surrounds the center conductor, the copper conductor. And heavier cables will have more than one braid. Some of them will have an actual aluminum shield around the dielectric, and then they'll have another braid over top of that, and some of them will have an aluminum shield and then braid and then another shield and another braid. That's called quad shielded. But it all works out the same, and they're all trying to do the same thing. They're trying to mitigate interference caused by induction from electrical, well, just your standard 60 hertz in North America or 50 hertz over in Europe. That's running through the air from our power lines. So what happens is, you got a long cable. And you get some power line induction. This is my power line induction, not drawn to scale. And that can get into the cable and cause a hum on the other end. So the idea of a balance line is you take your microphone or your guitar or whatever, you run it through a matching transformer that takes your high impedance and takes it typically down to 600 ohms low impedance. Now you've got your center tap, which is your ground, and you've got a positive and a negative output. So if your incoming signal was that, you'd have on the positive wire, you would have a representation that looks just like it at a slightly different level, and on the negative wire you would have a 180 degree out of phase, but the same signal that went in. So you've got a negative copy of the same signal. Now these three wires transfer, a couple hundred feet to the other end, and they're going to pick up induction, just like your unbalanced line. No different. They're going to pick it up. Even though you get a shield on here, and some microphone cables are shielded, some of them will actually have a shield. They'll have the 3 conductors and a shield. Other ones will just have the 3 conductors. They don't care. They don't really need a shield because they're a balanced line. They're going to pick up influence. There's no two ways about it. But the beauty of this is the influence is going to be the same across the board. You're going to have the same influence across the board. On the other end, there's another transformer. So you take your positive and negative, and it'll also, of course, be on the ground. This will cause an out of phase effect because you are now going to remove the influence by means of phase inversion cancellation. So by using another transformer here, the influence, which is going to be the same across the board, is going to appear out of phase on the other winding. So your signal, your influence signal, would be the same on both sides. It's going to be canceled in the transformer, and now you get a nice clean audio signal out without the influence. That's the reason we use balanced audio, is we can go much greater distances without fear of influence from induction, from your power line or anything else that can cause induction. It's usually for low frequency hum though, from your AC power. Now remember, I said there's a positive and negative. Well, we only need to use the positive, or we could use the negative, it doesn't matter, but we only need to use 2 of them. So in this case, I'm going to use the positive. I'm going to wire these up. I'm going to hook my shield to the number 1 pin on both sides, and I'm going to hook my audio positive from my cable to pin number 2, and pin number 3 is not going to be used. And that's what we're going to do. I'm going to make up 4 connectors, 2 male and 2 female, so that I can use them on that Betacam deck, as well as other audio equipment that I've got that has got XLR connectors. And I have some tape decks. I have my DAT machines, for example, do have the XLR connectors, but they also have the regular unbalanced. So I've been using the unbalanced on them, but I can use them on both. Anyway, I'm gonna get the soldering irons warmed up now. We're gonna go ahead and make a cable with 2 male and 2 female, and that will conclude this one. And then we're going to do another one when I get into that Betacam deck. I'm going to try to get the meters working on it. We'll be doing that as well. But first things first, let's make the cable. I just went to the dollar store and got myself the cheapest audio cable that they had. So we'll see what's inside this when I cut it apart. And a couple of double female couplers. We used to have a term for these, but unfortunately a group got upset when we called them what we used to call them in the field. So we won't go down that road. There's all kinds of slang that was used out in the field for different types of connectors, and they're still used. I'm sure the terms are still used today, but if I say it here, they'll hang me from a yard arm. You notice they use the right pronouns, right, as well. Okay, so we got the cable cut. Let's see how bad this cable is. I have no idea. This is like the cheapest cable. This cable was $2, and I think it was $2.25. So it was cheap. Those couplers were, I think, $1.50 a piece. We're talking cheap. I'm not buying high quality. These were expensive. These were like $5 or $6 a piece for these. These are the most expensive parts on this little cable that I'm making up. And they are calling for snow tonight too. And by they, I mean the weather forecasters. This is going to be the first snowfall that we've had this year. Although the year is only 16 days old, but we don't get snow where I live here, or very, very little. So they're calling for a significant dump of snow. But being above freezing, it'll be gone in 24 hours. I'll start out by feeding the cable through an appropriate end. I'll start out by, I'll do the female side first. So we put our cable through, and the first thing I'll do is I'll open up the cable. We'll take a look at how bad this looks. I don't expect to see much shielding on these, and it did not disappoint. That's bad. It did not disappoint. Talk about cheap wire. This is why I can sell them for, was it $2? I think I paid for it. Yeah, $2. This is how they can sell these cables for $2. So when you go to the dollar store or any other discount place and you buy the bargain basement, you're getting, well, that. And as you can see, I don't think there's any shielding there at all. It's just a bare wire that's kind of going right beside the hot wire. So you're going to get what you get, and it's not very good. Okay, first things first, we're going to pop the cable through this little retainer. Not that it's going to retain anything because this cable's so thin, but we'll just do it anyway. And do the same on this one. Just pop it through there like that. Okay, I'm interested in pins number 1 and 2. And they are labeled 1, 2, and 3. I'm only interested in pins 1 and 2. And it doesn't matter, right, which one I do, as far as the left and the right channel goes. Just going to strip this back here. Wonder how well these wires are going to hold out. One yank and they're going to break, guaranteed. But it's not like it's going to see a lot of use. Twist the wires together here. And I got something else I'll put on this video as well, because I did this the other day. I just didn't bother to upload it, but we'll put it on this video too, so I'll keep you guys guessing. No, well, I won't have to keep you guessing. What it is, I wanted to see what would happen if we tried to record Betacam signals onto a regular beta cassette, not a metal tape, but just a regular ferric oxide beta cassette, like the original Betacam did. And all the original Betacams, looking for my roll of solder, it's here somewhere. All the original Betacams used the standard ferric oxide tape. It was when they went to the SP line that they changed to a metal formulation, and it's because the SP format used higher frequencies to deliver a better picture and better signal to noise. The machine I've got will play back Betacam regular tapes, not Betamax, which is consumer beta, but it'll play back the Betacam, standard Betacam tape, as well as record and play Betacam SP. So I was wanting to see what would happen when I put a regular ferric oxide tape into a Betacam recorder, or Betacam SP recorder, as I wanted to see what the results would be like. And I will show you that in this video nearer to the end, just for those of you that want to hang around and see a little experiment done. And I won't let the cat out of the bag as to how good it looked and whether it's even possible to do it. Does it work or not? I'm sure some people have tried this, so some people out there that have this equipment will already know the answer. I didn't know the answer, so I wanted to find out, and that's exactly what I did, and I did find out the answer. And the answer might surprise some people. Actually, the outcome might surprise people as to how well it actually did perform, or how well it didn't perform. I'm not letting the cat out of the bag on this one. You'll have to wait and find out. We all know that you can take a regular VHS tape and drill a hole in it and turn it into a super VHS tape, and the results were very, very good. You can do that every day. I did it for years. I didn't go out and buy expensive $20 super VHS tapes for just stuff I was recording off TV and only going to watch a couple times and then erase. Hell no, I used regular VHS tapes to do it. and I think those are the right ends that go on here. Oh, did I put the right one or the wrong one on? I think that's the right one. Don't even know how these things go together. I know that this plugs in here, and it slides down through there, and then this piece should come on the back here and push that through. I think that's how it works. Yeah, I'm pretty sure that's how it works. And then this screws down over top. You see, that's how these go together. And that's supposed to hold the wire in, but of course the wire I've got is not thick enough, so a good tug on there would rip it out. So I'll just have to make sure that I don't rip it apart. Anyway, where was I going? Oh yes, we all know that you can take a regular VHS tape and punch a hole and drill a hole in it and turn it into a super VHS, and you can do the same thing with 8mm. I mean, how many people had high 8 cameras and they use regular 8mm tapes on, and to do high 8, or how many people did the same? I used to do it with digital 8 all the time because I didn't want to have to buy high 8 tapes to record some stuff on digital 8, and there was some long tapes that I used to use for digital 8. They were called P6180s. They were a 180-minute tape, which of course would give you 90 minutes on digital 8, which would work fine, but I wanted to use the LP speed because I wanted 2 hours and 15 minutes, and that required a high 8 tape. The digital 8 camera would recognize whether it was a high 8 tape or a regular 8 tape, because you could use regular 8mm tape on digital 8 and it would work, but it would only work at the standard speed. It would not work at LP. You needed a high 8 tape to go to LP. Now the thing was, LP was, well, a tape that would run for 60 minutes would run for 90 minutes in LP. A high 8 tape, a P6 120 high 8 would run for 90 minutes in the LP speed. But what if you needed more than 90 minutes? Which I very often did because I was doing weddings and they needed 2 hours and sometimes a little more than 2 hours. They didn't make any of these 180-minute tapes in high 8 format. They only made them in regular 8 format. So I used to punch the hole on a regular 8 tape so that my digital 8 deck could run in LP speed and give me that extra long recording. Because as those of you who know, DV and digital 8, there was no difference in picture quality when you dropped to the slower speed, unlike with analog recordings where every time you slowed the tape speed down, the picture got inferior. On digital, that didn't happen. You got the same picture quality whether you were using the SP or the LP speed in digital. What did happen with digital though was, if you recorded in the LP speed, you basically had to play the recording back on the same machine that made the recording. You lost all your interchangeability by recording in the slower speed. And see, I just messed up here because I neglected to put the wire through the end first, so I gotta take this off. I'm not engaging the brain before opening my mouth because I'm talking to you while I'm doing this. Anyway, so I get away with it with high 8. I get away with it with Super VHS. Will I get away with it with Betacam SP? Should work. Why not, right? You'll have to find out. So I'm just going to complete this and do the other side, and then we'll have some adapter cables that are ready for to put into service for when I need to record audio and play audio. I had to make these up anyway because with this deck that I bought, the reason I bought it was not so much to use it for a production tool because nobody uses tape anymore, but I did pick it up because, as I mentioned in the video where I evaluated it, was that I do get tapes brought to me every so often. I'll get a Betacam tape, and I really hate having to send it to somebody else to have them do the work. I don't like to help my competition out if I don't have to. So that's the reason I picked it up, and it was a good price. So, but it's got problems, so we need to solve those problems. Anyway, that's these two done. I'm just going to do the other two. I don't think I need to. Do I need to do my camera? I think that's pretty self-explanatory on these. Where do these go? These go in which way? I'm just looking to see which way these go together, because I've had different types of plugs that go together different ways. Some of them you put them together from the front, you pull them through to the back, and others you push them through. I think these ones push through from the back side. Yeah, these ones go through like that. So I've done switchcrafts before, and those ones you put the cable right through the connector, and you put the end on it, and then pull it back and tighten it up with a screw. But these are cheap. These are cheap. I mean, the quality has not gone into anything these days, including audio cables and connectors. I used to use all switchcraft stuff in some of my other cables that I've made up. My microphone cable, I got one hanging right here. Got the nice switchcraft ends on it. But I think if I were to buy those ones today, they'd be a lot more than $5 a pop. They'd probably be like $20 a piece, because just everything has gone up so much in the last couple of years. Price has gone up and the quality has definitely gone down. So we're going to connect these the same. Pin 1 is the ground, pin 2 is the hot. These ones are also labeled here. They're labeled on the front. There's pin 1, so pin 1 is that one, and the other one here is pin number 2 over here. So ground and hot is what we're going to do on this one. I just can't get over how cheap these cables have become. I was going to cut apart an old cable, and I thought, nope, the old cables that I've got here are probably built to a lot higher standards than these new ones, so I just went and bought a cheap new cable, and well, now we see what they look like inside. They are just a joke. Okay, that one's done, and now this just slides into the back here. And you push it down with the back end that seats down here. That pushes the connector all the way in. So to get it pushing all the way down, and then this will screw on there. Of course, a quick, easy way to test these to make sure that they're wired correctly is just to plug them together, and we should have continuity. Don't know which is which, so this way we can also identify if I've got them backwards or not. Okay, put the meter on in just continuity mode, and I can just test my hot, which is good. And I can test the ground, and I just so happened that I got them the right first shot. I got them right, and this one here is obviously got continuity, as does the tip. Now we want to figure out which one's which. I can just unplug one of them, and now which one's got continuity. The one that's got continuity is the one that's plugged in, and it's not that one. So this one here is obviously the right channel, so we'll mark these ones. Right channel, right channel, and this one would then be the left channel. Now we know which goes with what plugged on the tape deck or video deck or whatever we're going to use these cables on. Simple as that. I know that. Okay, I've only got the left plugged in, so we will get a beep on the meter. just for those that are still dazed and confused. Okay, there. So that's simple. That's how we do that. And now you can see the bonus footage that's coming up. And then we'll be doing one at some point today. I think I'll be putting that Betacam recorder back up, and we're going to try to get the front panel working properly on it. So I wonder what would happen if we took a regular Betamax tape and put it into a Betacam SP deck. Well, obviously it's not going to record. If the tape was recorded on a standard Betacam, then yes, it would play it back. But these machines only are set up to record in the SP mode. That requires a metal tape. The difference is well, the metal tape has these detection holes that the regular tape does not have. But what if we were to add the detection holes? I mean, it's pretty easy to see where they go. They go right here. So what if I were to drill or Dremel some detection holes and turn this into, well, what the machine would think is a Betacam SP tape? Now, I don't need to even go that far as to drill it. All I need to do is open up the shell and swap the base. Or should I just cut a hole in it? I mean, it's just as easy to little Dremel a little hole there. I just want to make sure that the filings don't end up in the tape itself. So maybe we'll do that. I'll pop the tape apart, remove the tape itself. I can find a screwdriver that will fit. Got lots of them around here. It's been a while since I've opened up a beta cassette. This is a master tape from the 1980s. Someone's old wedding from many years ago. I don't think they'll be coming back to me now to get it copied onto DVD. I'm sure they already had that done. Last time I had someone do that was a guy that I work with, or used to work with. He's now retired. Was hired 2 weeks ago, or hired 2 weeks. He was hired 2 weeks after I was at the phone company, and oh look, I don't even have to worry about crap falling into there because it's sealed away. Excellent. So I can just Dremel this away and remove the tape, get the tape out of the way, and we'll just Dremel that the detection holes and turn this beta tape into a Beta SP in the name of science. I think I got what I needed to do here. I can get that got okay. We'll put the tape back in. Sony always frowned on using regular Betamax tapes in Betacam because they said that the shells were made to higher precision to handle the higher speeds, but who knows? They look pretty similar. I guess I could open the other one up and do a comparison. Of course, this won't affect it as far as a regular beta machine goes. It won't care because it doesn't see those detection holes. That's why I took it apart, just in case I went a little bit too far, which I did, but no problem. I should have the detection holes covered. Interesting. This has got a tab over here and a tab on the other side for the record lockout. The Betacam tape has the record lockout on the opposite side. It's on the right side looking from the bottom as opposed to the left, and they actually punched out the record tab on a Betamax machine. So if you put a Betacam tape in, you would have to cover that hole on the left or it wouldn't record if you tried to record on a Betacam tape on a Betamax machine. Couldn't do it with an SP tape though, however, because it's a metal tape. That would damage the heads pretty quick on a regular beta machine. Okay, I'm going to try loading this cassette now that I've modded it. It'll advance the tape a bit here to get past that leader. Question is, will it enter record? It does look like it's going to enter record. I got to start my source up again here because it stopped. There we go. Let's hit record and start this up and see whether it will record. The tape is spinning. I'll switch this over to the... I got a message on here that says alarm. Reference video is not detected. Input a reference signal. Well, I don't have to do that. Let's just see whether this thing actually recorded anything on this tape. And it did. And the results are exactly as I expected they would be. Not very good. That's because the tape itself doesn't have enough bandwidth, but we'll take a look at how bad it looks. So that's how bad it looks. And that's because the recorder is trying to... Someone's wedding that was there before. I didn't want to wipe too much of it. I only recorded a few seconds, but as you can see, it doesn't record very well, which is what was expected, but this was an experiment. Thanks for watching.